We've moved on now to section 9.2, and in section 9.1 we were practicing and reviewing how to solve right triangles. Well, now we're going to talk about in this section and the next section how to solve triangles that are not right triangles. And so in section 9.2, the law of sines will help us with three particular types of triangles that are not right triangles: the side angle angle triangle, angle side angle, and then side side angle. So the law of sines is really pretty easy. I've written it for you in green. You're basically going to be setting up a proportion, and any of these can be used. You can do sine of the angle A, if you know what it is, over side A. Maybe you know angle A, but you're looking for side A, and you know angle B and side B. Then you could set up this proportion. Or you could do the same thing with angles B and C and sides B and C. So the bottom line is, obviously, you're going to have to know, however you put these together, you're going to have to know three of these. Either angle B, sides B and C, you're solving for angle C, that kind of thing. So I'll show you how this works with some particular examples. I went ahead and wrote the answers up here for you, and here's how we get those answers. So for this triangle, it's not a right triangle, obviously. Let's go through and find the missing parts. So for example, I can find, if I wanted to find side B, then I'm going to use the angle across from B. Okay, so that's angle B, of course. So sine angle B, which is 45, over side B is equal to, now I'm going to have to use an angle and a side, the angle and its corresponding side that are given. And so that would be sine 95 divided by its corresponding side length, which is 5. All right, and so you have a proportion, we have one unknown, and so you can do cross multiplication. So if I multiply 5 this way, I get 5 sine 45 equals B times sine 95. And obviously, to solve for B, I'm just going to divide by sine 95 on both sides. So it's going to look like this, and then we're ready to use our calculator. All right, so you can literally, if you use parentheses correctly, you can key this all into your calculator. I usually just obviously put parentheses, now with it being sine. Since we're multiplying, I would just put parentheses around this entire top part. Depending on the calculator that you have, you can try it out, and that's one of the reasons why I wanted to give you these answers. Try this out and make sure you can get it. So 5 sine and 45. I'm using a different type of calculator on my iPad, so the process is a little different. And sine 95, and rounded, that's 3.55, so that checks out. Okay, so again, just make sure you understand how your particular calculator works to come up with these answers. And now let's work on finding side A. Angle A isn't given, but it's implied that since the sum of the angles add up to 180 degrees, we could just do 180 minus 95 minus 45, and we get 40 degrees for angle A. So that one's pretty easy. And now we can find side A by using law of sines. So let me just show you how that works. Just use a different color. So I'm going to do sine of the angle A, which is 40, divided by side A, which is what we're looking for. And then you can use either one of these other angles and corresponding sides. Now that we know what B is, we could use B, but I like to stay with unrounded side measurements whenever possible. So I'm going to go with that same sine 95 divided by 5. All right, so it's very similar to what we did before. We're actually going to multiply by 5 sine 40. But this time, instead of sine 45, we'll be doing sine 95. A times sine 95. Okay, and you can see that we're going to be getting our answer by doing 5 sine 40 divided by sine 95 in our calculator. And that should give us A. So let's check it out. 5 sine 40 divided by sine 95. And that's 3.23 rounded. And so that checks out. So we got the angle, the missing angle, by knowing the 180 degree rule. The sum of the angles equal 180 degrees. And we illustrated how the law of sines works whenever we're trying to find these missing sides. Okay, so let's try another example. All right, similar type of problem here. We can go ahead and figure angle B, 180 minus 85 minus 50, and that's that should be angle B here, is 45 degrees. All right, and so let's work on, for example, finding side C. All right, so I can set these up, this angle with this corresponding side. So I'll do sine 45 divided by 3. And I'm going to let that equal this angle, which would be considered angle C since it's across from side C, divided by C. And so you're always setting up a proportion, and you'll have a missing component, and you just solve for that piece. So doing cross multiplication, sine 45 times C is equal to 3 sine 85. And so in our calculator, we're just going to divide 3 sine 85 divided by sine 45. So let's check that out. 3 sine 85 divided by sine 45. And that's 4.23. So that's what we got for side C. And then the only thing left, using law of sines again, is to find this missing side over here. So once again, I'm going to use unrounded side lengths. So I'm going to do sine 45 over 3 again. This time I'm going to do sine 50 divided by A. Okay, and just go through. A sine 45 is equal to 3 sine 50. And so in our calculator, we're going to do 3 sine 50 divided by sine 45. And let's see what that is. Sine 45 and 3.25, so that checks out. Okay, so you're getting a taste of how the law of sines works. Sine of an angle divided by the corresponding length of the side opposite that angle. Okay, here's another example, just for practice sake. So let's see if we can figure out the missing pieces. Angle A, of course, has got to be 40 degrees. Using 180 minus 100 minus 40. So let's see if we can figure out what side C will be. So that will be sine 100 divided by C, angle across from side. And we have to pair this up on the other side of the equation. We have to use an angle and a corresponding side that are given. So it'll be sine 40 divided by 2. And cross multiply. 2 sine 100 equals sine 40 times C. So in our calculator, we'll do 2 sine 100 divided by sine 40. And round it, and that should be 3.06, but we'll check it out. And that is correct, 3.06. We don't really have to go through law of sines for this side. I mean, you could if you wanted to, because if this 40-degree angle has its opposite side of 2, then this one also has to have an opposite side of 2. So it makes it kind of easy when two of the angles are the same. All right, but that is an illustration of the law of sines, and this is another example. All right, so let's, if you need to, you can draw the triangle, but obviously I'm looking for side A and B, and we'll infer that angle C is 100 degrees because of, again, 180 minus 40 minus 40. So we can try to find side A using sine of angle A divided by A, and we'll do sine angle C, since we know what that is now, divided by the side C across from it, which is 2. So 2 sine 40 equals sine 100 A. So in our calculator, we'll just do 2 sine 40 divided by sine 100. And when you do, you get A is rounded 1.31. And we have that same situation that we had previously. Since A and B are the same angle measurements, the sides across from them have to be the same as well. And so the answer to that is, side B is also 1.31. Okay, so that should take care of getting you ready for these problems. This is the assignment for section 9.2. And if you have any questions, let me know.